Hello students, myself Jitendra Gurjar, Assistant Professor, Mathematics Department. Today I am going to teach you application of ordinary differential equations. In this video we see very important example for exam point of view. Please watch till the end. So here we can see today I am going to see what are the applications of differential equation. Before that I am going to give you the definition, formula and we'll solve the examples given below. Here we see the first application, that is law of natural growth. So here we see what is the definition. Let x of t be the application at any point t. Assume that population grows at a rate directly proportional to the governing this phenomena in the first order first linear equation. So we just take the first order equation and which is linear. Okay, here we see dx upon dt is equal to kx, where k is a proportional constant. Here k is greater than 0 since this is a growth phenomena. So this is a very important application where we have for ordinary differential equation, that is a growth phenomena. And in ordinary differential equation you can see directly we take the solution. What is the solution? Yes friends, this is the solution of differential equation, which is given as x of t is equal to c into e raised to kt. Here we can see easily friends that as the growth increases we always take the exponential growth, which is sudden growth we are going to take. So therefore the solution is some constant we always there, plus or minus there will be some constant, and we have taken the growth of exponential. Here we see this c is some constant of integration, where c k are determined from the two original initial that is given. So the initials will be given in this natural phenomena or natural growth phenomena, what we say. Okay, so we are going to solve the example students. Here please write down the example. The first example I'm going to start. Before that we can see today we have started with the application of ordinary differential equation, which is on the screen. Here we can see today I'm going to teach you law of natural growth. In my next video I'm going to teach you that is law of natural decay. Yes friends, please like and subscribe if you like more, and subscribe, it will be motivated me to go to the next video. So I'm going to immediately make the next video. Within 15 minutes I will simplify this example. So here please write down the example. Bacterial population B is known to have a rate of growth alpha and beta itself. If between noun, so this is given it as, I think it's grammar mistake, it's a noon and 2 p.m. the population triples. At what time? No control being exerted, should B becomes 100 times what it was at noon? This is a very simple question. So understand the question students, very easy. So let us start simplifying without wasting the time. So please ready with the pen and paper. Immediately write down the example. So here I am going to take the example students. So first I will select the pen. I will consider this is a red pen I am going to take. Okay, here I have. We'll start with solution. So what are solution here students? First, this question is identify, this is rate of growth. So natural growth, this is a law of natural growth, we can easily identify. This will give you the idea of law of natural growth. You have to identify this, very important. Then immediately write down the equation. Here they have given bacterial population B, they have given a letter B. So I am going to take this. B is nothing but our population. Okay, so let us take this population and start our equation. So what equation will be? Yes friends, so previous slide I have shown you how the equation you are going to write. So this is bt upon dv upon dt is equal to k into b. Here you can see the variable in the formula is given it as x, but in this example x, we are going to take this variable as b as population. This is the reason where we have taken the b. Is it clear, students? Okay, so we have taken the solution. Now immediately write down the solution, whose solution is, yes students, in the previous slide I have given the solution. Please go through that solution and see what is the variable I'm going to take. Directly I'm going to put it in the this solution. So solution will become here bt is equal to c into e raised to k t. Okay, so this is what we get this. So this is the beautiful idea about the differential equations. Easily we can see any equation is given, directly we take the solution and then we simplify using the initial condition. That is what I said in the last slide. You can just go through the last slide and come back to this point. Okay, now we start with the initial. Always please remember this, whenever we start any equation we always consider the initial values. What is the initial? What is the initial of the growth? Keep it in the mind always, friends. Fix in your mind, initial will be always 0. Okay, let us start with this. Let I will say that at b naught, that is initial 0, be the initial population at t is equal to 0. So using the condition, I will use the condition, using the condition. So this you cannot, if you don't write it at in the exam, it is okay, no problem. So using the condition, I am going to say this is b naught is equal to c e raised to 0. Therefore you can easily find c is equal to, I have found out that is initial c is equal to b naught. Thus now I am going to get the equation, students, that is b is equal to, substitute in the equation 1. So put in equation 1, we get the solution. So this is very simple. B is equal to b naught e raised to kt. So when you get this equation, students, definitely you will get here, remember, 2 marks. Sometimes in this is an application part, therefore we always prefer to give 2 marks. So maximum you will get 4 marks. So it depends on what you have written the content properly, you will get the marks. So this is very, very important. Marks distribution I am also telling you. Okay, so we get here 4 marks. So since the population triples, so here I am going to use this condition now, remaining, yes. How the population triples? B will become 3b. Then 3 times the population means 3b I am going to take. Okay, then when we get the 3b, so in the initial condition it will become 3b naught. From the beginning it will become 3b naught between noon and 2 p.m. in 2 hours. So between noon means 12 p.m. and 2 p.m. So how many hours are there, students? 2 hours. So therefore I will take the time t is equal to 2 and I will use this condition, population triple. So I will use at noon to 2 p.m. Am I right? I will use the condition. I am going to take t is equal to 2. So there are 2 hours. Noon means 12 p.m. to 2 p.m. The time between this we have taken 2 hours. So t is equal to 2 I am going to turn. At this time we can see the population from initial will become 3 times, that is triple. So I'll say this is triple, I'm going to take this as 3 b naught, or the population b will become 3 b naught. That's a very simple friend. So I'm going to substitute in the equation 2. I will consider this equation as put in equation 2. We get, yes friends, so what we get here, yes, it is 3 b naught is equal to b naught as it is, no change, e raised to k is constant as it is, t into 2. So I think I will get b naught will get cancelled, so this is 3 is equal to e raised to 2k. So e, if I simplify this side, you will get this as a ln 3. Okay, ln 3 is equal to 2k. That implies k is equal to 1 upon 2 ln 3, which is equal to, just I will make it here, so somewhat you will get 0.54930. Okay, this is what we get the actual the answer. So there we find out the k value. Now remaining, I'm going to simplify the remaining part. I will simplify the remaining part, students. Here just I want some space. Okay, so I'm going to use this k in my next equation. I'll put it this k in my equation number 1. So the population will change at this point. Okay, let us try. What will be the population? Okay, so thus equation 2 becomes, so after simplifying this came, just a minute, let's select the pen once again. Okay, so therefore we get k is equal to 0.54. How much we have calculated? In the calculator easily you can calculate this ones. It is 0.54930. So put in equation 2, we get what we get this ones. Therefore the population changes. So hence, so we'll take hence the population is, what is the population now? It is bt is equal to b naught e raised to 0.54930 t. This is what we get from equation 2. This equation I have just substituted here k value. That's it. In this you will get another 1 marks. So hardly this will be for 7 to 8 marks. So here you will get 1 marks. Now I want to find the value of t. So I say that to find t, then when you find t, that is our problem. So what is they saying? The problem is question, you can see easily that should t becomes 100 times what it was at known. So they want you to find at time t what will be the b becomes 100 times. Okay, so let us use this condition now. Next condition, I want to find t here friends, but here you can see the population is becomes 100 times. So how you are going to simplify? So I say that to find t, b is becoming 100 b naught. That's it. B is becoming 100 b naught. That is 100 times it is going to become here. So therefore that implies I will take here now, I will put in the new equation. I will consider this equation now. I will consider this equation as equation number 3. I will put in equation 3. Therefore, now this will be 100 B naught is equal to B naught e raised to 0.54930 t. B naught will get cancelled. Again, you can see you will get here e this side, so you will get here ln 100 is equal to, when you take e exponential, when you take on right hand side, so it will become ln 100 0.54930 t. Find the value of t, students. Immediately put it in calculator. T will be equal to ln 100 divided by 0.54930. If you substitute in the calculator, you will get 8.3837015. Okay, that's it, students. Therefore, at t, that is 8.383715 pm, population becomes 100 times the original population. This is the answer from. So like this, you can easily simplify the remaining example, students. After simplifying such examples, you will come to know you can easily simplify the remaining examples. Thank you for watching my video till end, students. Notes will be uploaded in the description box. Please watch other videos given in the description box. I have made different playlist for different topics on my channel. I have made all semester videos. Notes you can download it freely, students. You can download the notes, download the videos. Only I ask for like and subscribe my YouTube channel, Engineering Made Mathematics for All Easy. And my next lecture, on my next video, I'm going to simplify the nature law of natural decay. Yes, friends. So if you like this video and subscribe, I'm going to make the next video. Yes, friends. Thank you so much for watching my video.